video, we'll be talking about algebra in terms of direct and inverse proportionality. In the previous videos, we have already mentioned a basic operation on algebras, and we have already mentioned the law of precedence. But today, we'll be seeing the application of algebra in terms of direct and inverse proportionality. But how can we explain the concept of direct and inverse proportionality? Let's take for an example, we're having something like this. Let us say we have something like y equals to 3x. We notice that for every corresponding value of x, there is a value of y as well. Or should I say for every corresponding value of y, there is a value for x as well. Which means in this case, if x equals to 1, therefore y equals to 3 times 1. That's equals to 3. If x equals to 2, therefore y equals to 6. Right? And it goes like that. Which means in this case, the x is termed the independent variable and the y is termed the dependent variable because x depends on y. Y depends on x rather. Y depends on x. Now, if the value of x now increases, the increase in the value of x now leads to the increase in the value of y. That is what we refer to as direct proportionality. But if the increase in the value of x leads to the decrease in the value of y, that is what we know as inverse proportionality. I get me now. And this proportionality is given by a symbol, or it is represented by a symbol. This is the symbol that we use in representing proportionality. And to cancel the proportionality, we use a particular figure, which is K. That is constant proportionality. Are you getting me now? So let us take for an example. We have different laws in physics and chemistry. And one of the laws that we have, I'm just going to use the law to show you how we can represent a particular statement, in using a particular alphabetical expression or alphabetical symbol. So Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure, provided that temperature remains constant. So if you want to represent that one mathematically, the volume of a fixed mass of a gas is inversely proportional to its what? To its pressure, provided that temperature remains constant. So if we want to do this one now, we have to remove this constant proportionality. And in removing constant proportionality, we are going to say V equals to K multiplied by 1 over P, which means V equals to K over P. And this is what you have. Now, Charles' law, let us use another equation. This is the statement of what? Of Boyle's law. Statement of Boyle's law. Charles' law states that the volume of a fixed mass of a gas is directly proportional to its temperature, provided that pressure remains constant. So if you want to represent that one mathematically, we can say the volume of a fixed mass of a gas is directly proportional to its temperature, provided that pressure remains constant, which means volume equals to kT. So whenever you want to cancel this proportionality, you are going to represent it as what? We are going to represent it with equals to and what? And K. Very, very important. So that equals to V equals to KT. Hope you get what I'm trying to say. Now we have another law. I'm going to use another law. And the law is Hooke's law, which states that provided that elasticity limit is not exceeded, the extension of an elastic material is directly proportional to the force applied, which means in this case, force is directly proportional to what? To extension. That is, force equals to Ke, right? And these are the laws that we have. We have Ohm's law, we have Avogadro's law, we have general law of pressure, and we have different laws in physics, which I've already explained in one of our in our introduction to physics. That I said laws and theories are very, very important aspect of science in understanding science. Now, how can we apply this in mathematics? Let us now solve examples in these particular aspects. So this is our first example. They said if y is directly proportional, to x, which means we must know that y is directly proportional to x. And remember I told you, if the value of y should increase, if the value of x should increase, the value of y will increase as well. For what? For direct proportionality. Which means, in this case, they said if y is direct proportional to x and y equals to 2.48 and x equals to 0.4, what is the coefficient of proportionality? Remember I told you the coefficient of proportionality will now be equals to k, that is y equals to kx. So to calculate the coefficient of proportionality, we must make this a formula by dividing both sides by what? By dividing both sides by x. Which means my k will now be equals to what? My k will now be equals to um, y upon x. What is my y? My y is 2.48. What is my x? My x is 0.4. If you press your calculator and 2.48 divided by 0.4 is going to give you 6.2. That is your answer for your constant proportionality, right? They now said the second question to be, what is the value of y when x equals to 0.65? One thing you have to know is that to know if you are correct or not, look at the value of x that is here. You see that is 0.4. But the value of x that is here is 0.5, 0.65. So which means the answer that you must get for your y must increase as well, must increase from 2.48 to anything that you want to get, because it is direct proportionality. Increase in the value of x will lead to the increase in the value of y, which means in this case, they say 0.65. Now, which means, remember, it's equal to y equals to kx, right? And what is our k that we have here? Our k is 6.2. That's 6.2 multiplied by what? What's our x here? Is 0.65 multiplied by 0.65. If you should press your calculator, 6.2 multiplied by 0.65 will give us 4.03. And this is our answer for what? For our y. As simple as that. But can we do more questions on this particular aspect of mathematics? Let's take for an example. The electrical resistance of a piece of wire is inverse proportional to the cross-sectional area. When area equals to 5 millimeter squared and R equals to 7.02 ohms, determine the coefficient of proportionality and the cross-sectional area when the resistance is 4 ohms. Simple. The first thing you have to notice this inverse proportionality, right? Which means our R, which is the resistance, is inversely proportional to the area, which is the A. Therefore, we can say R equals to what? Equals to K over A. To look for the constant proportionality, what are we going to do? We are going to cross multiply. Therefore, our K equals to RA. Now we can input our value of R, which is 7.2 ohms, and we can use the value, we can input the value of A, which is 5 millimeter squared. Therefore, we can say that our K equals to 7.02 ohms multiplied by 5 millimeter squared. And that will be equals to what? That will be equals to 36. Our answer is 36 for this particular one. Now, so we should calculate the cross-sectional area when the resistance is 4 ohms. Remember that it is inverse proportionality. What happens to the resistance? We see that the resistance reduces from 7.2 to 0.4 to 4.0, right? Which means the area must increase. That is what it's trying to tell us. Which means it must increase from 5 to something that is higher than 5. Now, let us do that. Remember that we said R equals to what? Equals to K over A, right? What are we calculating? We are calculating the area, which means we are going to cross multiply in this case as well. In cross multiplying, we have what? Remember I said R equals to K over A. If you cross multiply, the R comes here, the A comes here, because we are looking for what? We are looking for area. Therefore, my A will be equals to K over R. I get me. Therefore, my area will be equals to, what is my K that I have here? 36, which means 36 divided by, what is my R that I have here? 4 ohms. 36 divided by 4. And 36 divided by 4 will give us what? Will give us 9 millimeters squared. If you can see, you will notice that the resistance increases from, the resistance reduces from 4 ohms, from 7.02 ohms to 4 ohms. But the area increases from 5 ohms, 5 millimeters squared to 9 millimeters squared. That is how it works. Increase for direct proportionality. For direct proportionality, increase in x will lead to increase in y. For inverse proportionality, increase in x will lead to decrease in y. You have to know that. Very, very important. Now, let us solve another question. They said Boyle's law states that at constant temperature, the volume of a fixed mass of a gas is inversely proportional to its absolute pressure if the gas occupy a volume of 0.08 meter cube, which means the volume of the gas is 0.08 meter cube, right? They now said at a pressure of 1.5 times 10 to the power 6 Pascal, my pressure equals to 1.5 times 10 to the power 6 Pascal, right? Now say determine the coefficient of proportionality. Remember that they said Boyle's law states that fixed mass of a gas is inversely proportional, which means inversely proportional. The volume of a fixed mass of a gas is inversely proportional to a pressure, which means volume equals to K over P. If you should cross multiply, what are you going to have? Cross multiply, you're going to be having K equals to Vp, right? Which means you can calculate our cost proportionality here. Now, how are you going to do that? You can say K equals to, what is my volume? Is 0.08. That is 0.08 multiplied by, what is my pressure? 1.5 times 10 to the power 6. 1.5 times 10 to the power 6. Now, 0.08 multiplied by 1.5 times 10 to the power 6. You're going to have 1.2 times 10 to the power 5. And this will be your answer for this particular one. Now, the second question now says, if the volume of the, calculate the volume if the pressure has changed from 4, has changed to 4 times 10 to the power 6 Pascal, which means the volume has changed, right? What are we going to have? Look at it. We said volume equals to K over P. So we are looking for the what? We are looking for the pressure. We are looking for the pressure. Now, what are we going to do? Just like we used to do, cross multiply. Then our what? Our pressure will now be equals to K over V. What's our K? 1.2 times 10 to the power 5. What is our volume? 4 times 10 to the power what? 4 times 10 to the power 4 times 10 to the power 6, because it has changed to 4 times 10 to the power 6 from the question. And if you should divide it, you're going to have your pressure to be equals to 0.03. Sorry, volume rather. Volume. We are calculating volume. Oh, is it pressure? So we're calculating for the volume rather. And that will give us 0.03 meter cube. Simple as that. So these are questions that you can actually practice by yourself in terms of direct and inverse proportionality. Just try to practice this question, and if you have any answer, if you have the answer for your question, you can put it under the comment section. Or if you have any question in terms of any of these questions that I have given, you can type it in the comment section as well. If it is something I can make video on, I'm going to make video on it. And if it's something I can explain using text, I'm going to reply to straight away. Thank you for watching, and don't forget to subscribe for more. Thank you.